Okay. All right, kiddos, section 1.1, rectangular coordinates. Rectangular coordinates. I'm not going to go into tons of detail, but rectangular, why could it be called that? Aren't we going horizontal, or I should say horizontally and vertically to any point? Like you could think, or vertically and horizontally, you could think in a sense you're always going in some way in a rectangular fashion, like going over and up and over. Anyway, that's just a quick explanation as to why rectangular. But Cartesian, it's all from this math philosopher guy named Descartes, René Descartes. He did all kinds of stuff. But he was the one, the story is told, he was lying in his bed one night, or I think he was sick. There's like a kid's story about it. Someone gave me a book once. And then there was like a fly on the ceiling, and he was like, I wonder how I could explain to someone exactly where that fly is. And he was the one that started thinking of, I could mark my ceiling into units, and I could think of going over and up horizontally and vertically to that fly. Anyway, random story. But Cartesian, that's just from the guy's name. I learned in geometry what a plane is. So anyway, it's marking a plane into horizontal and vertical coordinates with some sort of reference point, which we call the origin, which can be different places if you're actually doing it with. What is the origin point? What's the XY coordinates?
0,
yeah, it's just 0, 0. No big dealio. Once again, I don't care if you write the word quadrant 4 times, but you know that 1 is the upper right, 2 is the upper left, then 3, then 4. We usually go or think about it in a circular fashion, like the unit circle. Y-axis is the vertical, x-axis is the horizontal. But if I was to come down here and label all of these points A, B, C, D, and E, which you can totally do in homework also, because when you go writing points in a graph, really quickly the coordinates get so messy. So letters are a much better way to go. Can I just ask you guys what quadrant each of these would be in? So letter A, it's going to be in the second quadrant because you have a negative x, positive y, so left and up if we were thinking about it, right? Okay, what quadrant would letter B be in?
1.
Because we're going right and up. True? Positive, positive 4. Whatever happens if you didn't make your axis quite big enough? Can we just estimate? Are we good with that?
Yeah.
Cool. So we have our B, we have negative 1, 2, we have our A. Where's our C going to be?
In the origin.
Yeah, it's not going to be in any quadrant, right? So C is just going to be the origin. So we go ahead and just label him C. D, where's he at? What quadrant?
4. 3.
Good. There. So let's use what Joe said. Yeah, we can just say it's the axis, right? Because you're going right 3, but up and down none. So on the axis. Technically, I would call this the positive x-axis. Do you guys know why? It's on the right side. Yeah, as to the left. What quadrant? Letter E. Got it. Left and okay. Why did I go through this? Plotting points. It's supposed to be like easy algebra 1 stuff. I know. The struggle is in homework, they didn't just give you points. Sometimes they gave you clues like, hey, in what quadrant is x times y negative? In what quadrant or quadrants is x times y negative? How would you guys answer that one? Let me write it out. In what quadrant or quadrants, meaning there could be more than one, is x times y negative? Let's do a vote. Let's do a vote. Let's do a vote. How many of you guys say quadrant 1 fits that? X times y is negative. How many of you guys say quadrant 2 meets that? Quadrant 3? The point of voting is to not be talking. Quadrant 4. Okay. Y2 and 4. I saw multiple hands in both, and you guys are right that both is the correct answer. Not just one, not just the other. What are all the x's in quadrant 2? And what are all the y's? And what's a negative times a positive?
Negative.
What are all the x's in the fourth quadrant? Y's? Is a positive and negative?
Negative.
But do you see how that's just a little bit harder than just plotting points? And yet it's using the same idea. Do you realize where positive x's are, where negative x's are, where positive y's, negative y's? So that's why it has to go through and think about the quadrants. Homework might go a little bit deeper, but still using the idea of points and your coordinates, your quadrants, and where certain characteristics are true. So it might be helpful for you to put a little sample point in quadrant 2 and say, hey, the x's are always negative, the y's are always positive. This might remind you a little bit of the unit circle, but that's not really what we're doing right now. We're just talking about always quadrant 2, negative x's, positive y's. How about quadrant 3? Always negative, negative. Quadrant 4, always positive, negative. And we forgot quadrant 1, but he's nice and easy because he's always good. Anyway, a few little things to put in, just thinking towards how this might get a little bit harder in the questions that they ask. Okay, are we good? You can always just stop me if you're not. Raise a hand if you don't want to talk. Pythagorean theorem. Easy cheesy, right? Pythagorean theorem. What kind of shapes are we talking about if we're talking about Pythagorean? Triangles or trig functions, but that's not for quite a while yet. Right triangles specifically. What are my legs usually labeled by in a right triangle?
A, B, and C.
A and B. Now careful, I didn't say C. The legs are usually A and B. Who's usually C? Hypotenuse. And in geometry, do you guys remember anything about the hypotenuse? It's the longest side in any right triangle, that's true. Do you remember anything about possible versus not possible triangles?
If the
the sum of both legs has to be close, bigger. There you go. Matthew was on the right line of thought, though. The sum of both legs have to be greater than the hypotenuse. Otherwise, it's not a possible right triangle. Now, this isn't quite geometry, so they're not necessarily trying to trick you as to whether or not it's even a possible triangle or not. But hypotenuse will always be the longest of any right triangle, and the sum of any two legs does have to be greater than the third. Did anybody ever figure out visually why that has to be true?
Because if it's not, like, it's snapped in the middle, and you cannot really make BNA touch anymore.
Yes. Good visualization. Let's try to catch everyone up, though. If A plus B was less than C, okay, imagine these were sticks. If A plus B was less than C, wouldn't that mean that putting those two together wouldn't even be long enough to meet on C? So as soon as you go off, they need to be even longer in order to meet. So the idea is if A plus B was ever less than C, when you go to form a triangle, they wouldn't meet. They wouldn't actually be able, you could try to shift it, the angles could be all different, but they would never meet. Anyway, that's the idea. What's the Pythagorean theorem? We didn't write it down.
A squared plus B squared plus C squared.
Leg squared plus leg squared equals hypotenuse squared, right? Now, how many of you guys would say remembering the Pythagorean theorem, like just off the top of your head, is easier than the distance formula? How many of you guys, hands down, would say that if I was to give a quiz right now, either 0 or 100% on whether or not, with absolutely no talking, half sheet of paper, no resources out, whether or not you wrote the distance formula down correctly, you would get 100%. 2, maybe 3. And they weren't very confident. This formula is harder, right? Can we admit? But here's the crazy thing. This formula is really just that formula. Distance formula. You're always finding the distance between how many points?
2.
Yeah. So let's label them. Let's label 1 point. Let's label another point. Just notation, x sub 2, y sub 2, x sub 1, y sub 1. Couldn't we, once we label our points, couldn't we also kind of like follow this down and say, oh, whatever this x is must be x1, and whatever this must be y1? Over here and label this guy 2, and this guy is y2. And then couldn't we technically make this whole little, we could even call it, if you wanted, this little distance, we could call him delta y. That's one way of saying it, change in y. We could also say that that is technically, just because we can, hold on, pause, just because we can see the picture, and we see that y1 is higher than y2, we would say y1 minus y2. Technically, if we were talking about the distance, we could just do absolute value and say, well, distance, I don't care positive or negative. I just care what's the subtraction, and I'll just make it a positive number. I just care how far apart they are. So if we wanted to make it kind of like generalized, like if the points were flip-flopped, we just want to be able to say the distance between these two will be y2 minus y1, regardless of the sign. What would the distance be between the x's? I could just say, I don't really care which way I'm subtracting as to who's farther left, who's farther right. I'll put an absolute value. If I can just say, subtract the two x's, I'll figure out how far apart they are. And what we just did is we said, hey, what's that distance? What's that distance? And the horizontal vertical meet at a right angle. So if we're trying to find the distance between 2 points, it's really just our hypotenuse. How would you solve for the hypotenuse up here? You'd square root. You solve for the hypotenuse here. You square root. And you could say leg squared plus leg squared. Now here's one crazy part. Where did my absolute values go? Why aren't they written? It's kind of a deep question. And what's true about when you square any number? It becomes positive, so the absolute value is redundant. Ooh, good vocab. Not for math, though. What's true if something is redundant? It's not needed because it's just being repetitive. It's repeating something that's already true. So there's no reason for an absolute value if the squaring already says that'll be a positive quantity. What's the distance formula? This guy. But who is he really? Pythagorean theorem. A squared plus b squared is c squared. Maybe that'll help some of you remember it. Maybe it won't. But it is sometimes cool not just to memorize these formulas, but to have some idea of where they actually came from. Let's get down to the examples at the bottom. So I didn't do an example of Pythagorean theorem because I was thinking we were probably okay on that guy as far as the basic application. So let's go ahead and use the distance formula. However, just to solidify the fact that it's actually Pythagorean theorem, some of you guys, if you like just taking a formula and plugging and chugging, go ahead. What do I mean by plugging and chugging? Yeah, figure out who's x1, who's y1. I don't know, just pick them, right? Who's x2, who's y2? I don't know, just pick them, right? Plug it in and then simplify. That's plug and chug. Okay? I'm going to do it a little bit more creatively. But if you want to just plug and chug, if that's what you like, taking and plugging in, totally fine. I'm just going to have a little more fun. Formula people, did you beat me? Maybe. Oh, you actually kept going. Does the formula work? Good. We have some people that have already gotten it. How does the formula work? Just in case you don't like my way, that's much more visual. You could have taken your x2 minus x1. y2 minus y1. Simplified, you would have ended up with 5 minus a negative squared is 25. 3 squared is 9. 9 plus 25 is, how did I do it? I used the idea of the formula saying, I just need to know how far apart. So I just counted 1, 2, 3, 4, 5. Sweet. How far apart? 5. The formula, the idea, the y's. I just counted 1, 2, 3. Sweet. A squared plus b squared is c squared. Pythagorean theorem. Both ways work. What's 8? Depends on your brain and how it thinks, whether it's more of an abstract plug and chug. I just like using what I have. Just a few of you guys are way more visual, way more concrete, and it's nicer to be like, oh, a triangle, I get that. Pythagorean theorem. Okay, last formula. I think this is the last one. Section 1.1 is kind of short. But theoretically, you might be starting to feel a little bit of how Precalc is different than Algebra 2. It's not just about the formulas, what to memorize, what to do. It's also understanding a little bit more of what's actually going on. And having some questions that definitely dig a little bit deeper into the concepts. Okay, midpoint. Geometry. What's the idea of midpoint? You have 2 points. You're trying to find the point at which the line is like bisected, right? So you're trying to find the point at which the 2 segments would be congruent. If you want to think about it that way. We have an x1, y1. We have an x2, y2. And we're trying to find the m. I did capital because little m's usually slope. So if we're trying to find the midpoint, some of you were like, oh, that was an easy formula. I have it right off the top of my head. Some of you guys are like, nope. So pause. Let me ask you a different question. How do you average stuff? Like if you have numerical data, how do you average? That's all you need. Add them together, divide by however many there are. How many x's do we have?
2.
Sweet. You want to average the x's and average the y's. Done. Midpoint. Average the x's, average the y's. Yeah.
Couldn't you just use the distance formula and then divide it by 2? And I'll get you the same answer.
I wish. You can think of illegally separating the distance formula with the plus and then dividing by 2. But the problem is the word illegal. But you can, yeah. Because what you're thinking of is, well, you have the squared square rooted, it cancels out. But that's an illegal distribution of, technically you're killing what we would call a puppy. Because you can't distribute a square root over pluses. And the second struggle is that the distance formula is a minus. So I would say just take that all out of your thoughts and just think averaging. Or just memorize the formula. So when we have this point down here below, the nice thing is with addition is the nice property is commutative, right? Meaning 2 plus 4 is 4 plus 2. -1 plus -5 is -5 plus -1. Addition is commutative. We actually don't even need to worry about the order like we need to in many other formulas like slope and distance, etc. Distance doesn't really matter either. So we could just take either of the x's and put it first and just say, hey, let's take the 2 x's and average them. Let's take the 2 y's and average them. Some of you guys have already beaten me. Good job. I was just explaining. -5 plus 9 is 4. 4 over 2 is. And -3 plus 3 is. And 0 divided by anything is. Dun, 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 dun. Okay. So homework, super easy. Just going to use these 3 formulas and then point plotting, right? Except it might go a little bit more in detail, a little bit more abstract, a little bit more complicated than I expect. But there aren't too many problems. So you're going to get a feel for our book. Number 1, you're going to get a feel for where to find the odds in the back of the book to check whether your odds are correct. When you come in tomorrow, if you guys just want to think about like the system, tomorrow homework will be due. Your Google Classroom should have been turned in far before even school starting. Not far before, but before school even started. You can pretty much clear your desk of everything tomorrow except for your composition book, ready to go into section 1.2 notes, which we will. Pencil for the note-taking, or pen if you use that. And then you're going to want your homework spiral open to the homework that's due for the day with a colored pen. Because you should have already on your own tonight graded the odds because they're in the back of the book, but what wouldn't you have been able to technically grade or check yet? Doesn't mean there aren't places online that you could probably find the question somewhere that's been worked out somewhere. But the point is you've been able to try and grade the odds and then the evens. It's kind of like your baby quiz for the day in the sense of, well, I did the best I could. Let's see how I did without having the answers to look at. Does that make sense? Then after we do that, we'll see what questions you had, either question marks on odds that you weren't able to finish or problems that you got wrong on evens that you still need to figure out what went wrong. There is one problem, the very last one of homework, number 58. There's a typo. So if you have something that in pen another student has marked out and written, use that instead. And if you don't, do the best you can and try to figure out what part of that problem is the typo, and we'll fix it tomorrow. Sound good? Cool. Bye, guys. See you later. Happy nutrition. Salma, let me grab you for a second to talk about the graphing. Yeah.